Hi, so here we have a differential equation. So we'll try to solve this by using the method of variable separation. Although when we look at it at the first glance, this particular differential equation cannot be separated. That's because we have an x minus y term. So what we will do, we'll start by assuming that x minus y is equals to, let's say, some variable v. Then we differentiate both sides with respect to x. So that will give us 1 minus dy over dx equals to dv over dx. Now isolating dy over dx, we will get 1 minus dv over dx. So what we will do, we'll consider the original differential equation and substitute dy over dx with 1 minus dv over dx, and that will be equals to secant of, we have x minus y, so that x minus y will now be replaced with v. Now further, when we rearrange the terms, we have dv over dx equals to 1 minus secant of v. Or we can do is separate the differential, so that will be dx equals to dv over 1 minus secant of v. So here we can see that this is now in the separable form, so we can integrate both sides. Integration of dx will be x, and that's equals to integration of dv over 1 minus secant of v. We know that secant of v, that's equals to 1 over cosine of v. So we have integration cosine of v dv divided by cosine of v minus 1. Now, in order to solve this integral, what we will do, so here we'll use the identity cosine of v, which is also a half angle formula, 1 minus 2 times sine squared v over 2. Simply cosine of v minus 1 will be equals to negative 2 sine squared v over 2. So let's use this value, then our integral will then become x is equals to integration. So in place of cosine v, we have 1 minus 2 times sine squared v over 2 whole divided by, so we have cosine of v minus 1, so that will be negative 2 times sine squared v over 2 times dv. So we have x equals to negative half integral, so we have 1 over sine squared v over 2, so that's cosec squared v over 2 plus integral dv. Now solving this integration is very simple, so we have x equals to negative half the integration of cosec squared v over 2, so that is negative cot v over 2 divided by half plus integration of dv, so that will be v plus the constant of integration c. So that means we now obtain x equals to, so the half and half gets cancelled, negative and negative becomes positive, so we have the cotangent of v over 2 plus v plus the constant of integration c. So here we have assumed that x minus y, that was equals to v, so in place of v we'll replace it with x minus y. So we have cotangent of x minus y divided by 2 plus x minus y plus c. So the x and x gets cancelled out from both sides, and we'll bring the y to the left hand side. So we have y equals to cotangent of x minus y all divided by 2 plus the constant of integration c, and this is the required solution to our given differential equation.